Now that we understand how to make asynchronous web requests to APIs, websites, web services using the XHTTP or the XML HTTP request object, as we see here in our past example from our previous video. If you remember correctly, we are making a call to the weather API, and we're making a call to this weather API address using our API key that we have. And we are using this XML HTTP request object. Now we learned how to use that object, and we learned that we create a new instance of that object using the new keyword, which invokes a constructor function which knows how to build. So this function right here, this is the name of a function, it knows how to build us this XML HTTP request object that we can then set up to make a request to this API URL that we've got right here. So this you should be familiar with from the last video. So now let's talk about the fact that with an asynchronous call, anything that's asynchronous in JavaScript, usually those objects, if they are provided to us by the API, will provide an event handler property to which we can assign an event handler. And if we remember from that previous video, there is a difference between the event handler and an event listener, right? The event listener lives inside of this object, and it is paying attention to the call that is made to this URL, and it is listening for the return from the web server that holds this API. Once that event listener that lives inside of this object and is handled by the browser's web API, as soon as that response comes back from our web service, our event handler, in other words, the function that we have custom built that does what we want it to do when we get data back from the web service, that gets called on this property of the XML HTTP request object. The cool thing about event handlers is that we don't necessarily have to do them in line like this. If we wanted to, we can actually take event handlers, we can pull them out, and we can actually make them reusable. In other words, more than one event could use that function. And all we do is we simply pull it out as a function instead of using an anonymous function, which is a function that doesn't have a name because we're doing it inline. We can go ahead and provide a name for this, and we'll just call this API return handler. And you can name it whatever you want. You don't have to use this name. And then we can go ahead and instead of using that anonymous function right here, we just go ahead and put the name of the function that we want called. Now, of course, we do not put the parens because when we do the parens, we're actually executing the function. We're telling JavaScript to go execute it. We don't want to execute it. We just want to provide the reference to that function that is held inside of this function name or this variable name that holds a reference to this function body that we have stored in memory. So that's a pretty simple change. Hopefully you understand that. If not, make sure you speak to your instructor or to one of the tutors. But right now, we just simplified this a little bit just by removing a function inside of a function. And we just moved that function out. We're providing a reference to that function to the event handler property on the object. This XML HTTP request object will then again has a listener inside of it that's listening for any data to come back from the web request. When that data comes back, our custom function, this one, which we have assigned to this property, will then be called internally by our XML HTTP request object. All right, so that's a little overview or a little refresher about what we talked about in the last video when we were talking about asynchronous events. Now let's talk about how we handle errors when we call a web service or web API. So this is extremely important because usually APIs such as this one, right? It's coming from, oops, that's not supposed to have the word bad in it. That's from when we were doing some tests. So this is actually supposed to be our weather API. So let's go ahead and get our weather API URL back. Let's go to Open Weather. We're just using our Open Weather API. and it's open weather map is the one that we're using. So I'll go ahead and pull this back up. So if you've forgotten, we're using the open weather map. And to make sure we've got the proper URL, let's go ahead and go to our current weather data. Let's go look at the URL, and we should just have open weather map in that place. Not bad. And we'll see why bad was there in a minute. I just forgot to reset it. All right, so we just went ahead and pulled our event handler out and made it a named function, and now we're just providing a reference instead of providing that async or that anonymous function for that. So let's go ahead and see what that looks like. Make sure everything still works. You always want to test stuff after you change it. We're going to want to go ahead and open up our web developer tools, and you can see right here API status changed to OK, and here's our data. So it looks like our call is still working, even though we're using a reference to our handler instead of an inline anonymous function. All right, enough about that. So let's jump into error handling inside of an asynchronous web request call. And of course, we're going to do that inside of our event handler. And inside of our event handler, if for some reason there is an error that happens on the API, so on the API at the web server, and it decides that an error happened, something was wrong, either we didn't provide the correct API key, we didn't call an existing function in the API, or we don't have a valid API URL. If we get some kind of an error, we've got to handle those errors. So the first two errors that I talked about, if we have a bad API key or if we have a bad method or function in the API, those are usually going to be handled gracefully by the API, by that web server, and we're going to get back probably a HTTP status code that tells us that something bad happened. If we have a bad URL, then that usually means no web server actually will handle the response, and we're going to get a different kind of error. So we'll see how to handle these kinds of errors if we have a bad formatted URL, or we have a bad domain, or we're calling a non-existent API. We're going to learn how to handle those errors after we learn how to handle errors that could be handled gracefully by the API's server. So let's start with that. Any error that has to do with the API, where the API will handle it gracefully, in other words, it'll recognize that we did something wrong and it will respond to tell us that we did something wrong, those kind of errors usually happen and are handled inside of our event handler. In other words, it's our responsibility inside of our event handler to check for errors. And if we have an error, then we need to do something to handle that error gracefully. And so we're going to talk about that right now. For that, we need to understand our HTTP error codes, and not just the error codes, but also our success codes. If you go to the developer.mozilla.org or the MDN, the Mozilla Developer Network, and you look up HTTP status codes right here, HTTP response status codes, that directly corresponds to the status that lives on our XHTTP object. When data comes back from the web server where this API is, we are going to have an HTTP status code that comes back with the HTTP response that we get back from this web server. That status code from the response is going to be stored on our XHTTP request object in the status property. So it's just like this, xhttp.status. And you can see right here that it is a property of our XML HTTP request object. This is how we would get to the status outside of the XHTTP object. So right here, this is what we would do. But since we are trying to check the status inside of our handler, our event handler, because our event handler, once it is assigned to this property, it actually becomes a function that lives on our XHTTP request object. Because of that, the context of this function changes from global to the actual XHTTP request object. That means that we can actually access everything on the XHTTP request object using the keyword this, because this is now bound to our XHTTP object because this function was assigned to a property that belongs to the XHTTP request object. You should remember this from when we talked about scope and we talked about this as it applies to objects in one of our previous videos. If you don't remember how this works inside of objects, make sure you go back and rewatch that video, talk to your instructor or talk to a tutor and have them re-explain that to you. I'm not going to go back into that. So with that, we can use this dot status in order to pull the HTTP response code that we got back from the API web server, which is now stored on this XHTTP object, which we can refer to using the keyword this. So once we pull that status, we will know whether or not the HTTP response was successful that we got back from our web server or from the API server. Here you'll see that HTTP response status codes, there's different blocks. The 100s are usually your informational responses. And so usually we're not worried about handling these. 200s are your successful responses. And you can see this status 200 OK means that the request succeeded. And if we look at this, we are already handling the successful status of 200. Because right here we're saying, is the ready state of 4, which is specific to the XHTTP object. So we're not going to go into that. You can go ahead and look that up on your own. But if the status equals 200, in other words, was the response received back from the web server, and do we have some information back from that web server, then let's go ahead and let's handle that here with this code. And then if we have anything else, in other words, if the ready state is something other than 4, let's go ahead and do this. If the status is anything other than 200, let's go ahead and do this. Well, here, inside of our previous example, we're not really doing anything to handle those errors. In all reality, we are simply spitting out a message with the status. And we can see that when we go to our console inside of our web developer tools, and we can actually see where it says status changed, but we've got nothing there. But then we have a status change with an OK, and it looks like those are our only 2 status changes, but you can see that this one with OK happened twice. That's why I got the number 2 there. And then we have our data here. Really, this isn't providing us any real value, you could say. And when it comes to dealing with HTTP responses, we want to make sure, let's go ahead and add this to our tabs here. We want to make sure that when we have a failure, in other words, if it is not in the 200 range, then we want to go ahead and we want to make sure that we handle those kinds of errors. And within our 200 range, we could actually handle some of these as errors. Right here, we've got a 204 no content. And that is that there was no content sent to us in the request, or there's no content to send for the request. And so the server didn't send us anything back because our request didn't require that the server send us anything back. So we could handle a 204, so that's probably one we could handle because there is the possibility we could get a 204 back from the web service telling us that there really wasn't anything that they could send to us. So we could think about handling that one. And then down here, the ones that we're really worried about are these client error response codes, like this 400 bad request, a 401 unauthorized, or a 403 forbidden, or a 404 not found, a 405 method not allowed. So all of these particular errors, we can handle and provide responses to our users, letting them know that something happened. And if the user needs to know that, number one, they don't have proper authorization to call that that particular API, we might want to let the user know that so that they can provide us with the proper and valid API key if we were allowing the user to supply this API key, which is something you might do. If we created a weather widget and we didn't want everybody calling our API key, you might require the user of your widget to go sign up for an API key, and then in the settings of the widget, they provide their API key, and then that's the API key you use to call. And if that API key becomes invalid, or if it exceeds its number of allowable requests because it's a free API key and there's limit restrictions on it, then you'll need to be able to tell the user that they're unauthorized, or that they have been forbidden, or that they have, there's a good one in here that can be used if they have tried too many times to call. Here we go, too many requests right here, a 429, too many requests. And that's a valid one right there that we could get back from an API because of rate limiting, where an API is restricting the number of requests that a particular API key is allowed to do. That way they can rate or limit the number of calls that are being made against their API and save themselves some money when it comes to free API keys. All right, so we've gone through these errors. Let's pick a couple and then let's go ahead and show how we might handle those. Here we're doing an if, and we're talking about the ready state, and then we're talking about the 200. So this is great. And here, really, if our ready status isn't a 4, I'm not really worried about capturing status changes in the API. So let's not worry about capturing status change issues. But let's capture some of these HTTP response status codes and handle a few of them. So here, if it is not a 4 on the ready state and the status is not 200, then we're not going to execute this code that ends up parsing our response and gives us our weather data. Instead, we're going to go ahead and provide some error handling in here with some messaging to our user that something has happened. So let's go ahead and down here, let's do something like handling let's do an unauthorized or a bad request. Let's see what happens if we were to take our API key, mess it up by adding a bunch of letters up here so we know it's not a valid API key. And then let's see if our web server actually gives us back a 401 unauthorized. So let's do a check on our status code, and let's check for a status code. So let's go ahead and say handling errors here. And then we're going to do a check for that status code. So if status code, and we're looking for a 401 unauthorized. So let's do a 401. And then let's just do a console.log to keep it simple right now. And then let's say, of course, it's an unauthorized, so you are not authorized. Your API key may be invalid. It's a pretty good error message right there. So now that we've got a messed up API key because we added all of these letters to it, let's go back to our request. Let's refresh and let's see. You are not authorized. Your API key may be invalid. So it looks like we're getting a 401, as you can see right here. From the GET request, our response came back with a 401 unauthorized, and now we've got a human-readable, user-friendly error message that is being provided to our user. Right now it's just a console-based application inside of our browser. But we could take this message and actually put it here in the web page simply by adding another element, referencing it, and then changing its inner HTML. So here we've handled one error, which is the 401. So let's go ahead and let's undo our crazy API key destruction that we did. Let's make sure everything gets called. Save. So something's still wrong. Maybe it's that F right there. Yep, it was the F. Okay, so now we've got a valid key again. Now we're getting data back. We're getting a 200, so everything's good. So we know that we are handling the status code 401. So what happens if we choose to call a service or a function on this API that doesn't exist? So let's say bad. Let's go back here and look at it. We got a 404 not found. So if we were allowing the user to provide or tell us which service or which function within the API they want called, we need to handle if they provide us a bad function, if we were going to be allowing them to provide us or determine which function we were calling. So in this case, calling this weather function actually provides us the current weather for today, but there are other functions within this API like forecast. We can call forecast with our API and we can get a whole bunch of data right here. You can see this right here. And this is because it's for the entire forecast every 3 hours for the next 5 days. So if we were allowing the user to provide this and we were doing a little string manipulation and letting them pick what goes in here, and they choose to provide us with a function that is bad, then we're going to end up with a 404. But you can see it's not handled here and it's blowing up our script. So we want to gracefully handle this and provide the user with an error message that is useful, which means we could put it back here in the UI and tell them that the function that they selected, maybe through a text box right here, is not a valid one. So let's go ahead and let's handle a 404 not found. And we do this simply following this same pattern. We can say if status is a 404, which is a not found, let's go ahead and change our error message to be something user-friendly. To be something user-friendly that helps them understand. So let's see. The function you requested does not exist. Please provide a valid one. So now we got a good error message. We can go back here and we see that we're still getting a 404 not found. Instead of our script blowing up, we are now providing a useful error message back to our user, which of course, if we were doing it in the HTML like we should be, with this error message would pop up here, probably in red, letting the user know that they gave us a bad function to call. All right, so now we're handling 2 of the 400 errors, which are our client response errors. So we'll just go ahead and stick with those 2. Those are probably the most common, a 401 unauthorized and then a 404 not found. Those are the most often encountered errors. So this is how you would handle errors inside of an asynchronous API call based on the HTTP response status code that's coming back from the web server, letting us know if there was something wrong with our request. And something wrong with our request usually has to do with something after the domain information we pass out, because this query string, which includes the path right here and then the actual variables and values or key value pairs that we're providing, which are called the query string. These are what usually end up in bad requests with a 401 or a 404. Now let's talk about how we handle errors where the URL we provide doesn't even get us to a valid web server. So let's go ahead and change this back to weather, just so we know that we've got the right thing. Now let's change this one to bad. Now api.bad.org doesn't actually exist, so this whole thing should give us an error. So if we go back to our web request right here, we're getting an error, name not resolved, and that is because this whole domain does not exist. So we're getting back an error. It's killing our script. So let's go ahead and let's see how we handle errors that are not gracefully handled by a web server because it happens over the network. Another thing that could happen, other than just having a bad domain or a bad subdomain, is that if there are network problems, our request may try to go out and we never get a response back. And our XHTTP request object, our XML HTTP request object, it has to handle situations like that, but it's never going to really call this API return handler because we're not ever getting anything back. For that, our XML HTTP request object, let's go ahead and pull that object right there, has an onError handler that we can provide a function for. And when all other kinds of errors that are not gracefully handled by the web server and returned to us as an HTTP response code in the error block of 400, what we get back is just straight up an error. Something bad happened, we have no idea what's going on. Either it was a network error or we couldn't find the domain or something bad happened. For that, we can provide a handler for that so that when an event like that happens, we handle it gracefully within our application. For that, we just need to provide an error handler. So let's say API error handler. And that's going to be the name of our handler function. And of course, I'm doing the same thing here. Instead of using an inline anonymous function right here, I'm just going to go ahead and create this function outside, just like we did with our API return handler. So I'm going to go ahead and put it right down here. It's a new function. That's what its name is. And when we receive an error from the onError event, when our event handler gets called, the XML HTTP request object will pass us back as a parameter an error object that we can use. So let's go ahead and find out how we can use this when an error happens. So here I've already changed this to bad instead of open weather map. And if we go back here, we'll see that we get this error, name not resolved. We've now got ourselves an error handler, but our error handler isn't doing anything. So let's verify that our error handler is actually getting called, console.log, and let's say there has been a horrible error. Let's go ahead and see if we've got that right here. There's been a horrible error. All right, and let's go ahead and look at our error object that we get. Let's do console.log, and let's just log our error message, our error object, and see what we've got there. So it's a progress event. It is an error, so type is error. And we can see everything that this provides us right here. And right now, it doesn't look like this really provides us with anything useful. But you can see that we are provided with an error object, and in some libraries where you have libraries that actually provide us alternatives to the XML HTTP request object that's built into the web API in our browsers, we can use other things like Axios or jQuery where this object is actually wrapped with a more complex object, and we can get back more defined and well-created errors that might provide us more information than this. Right now, this is pretty generic error and doesn't really do us any good. But you can see that we do have an error object that comes back, and that's important to understand. Also, just like here inside of our API return handler, because we are providing this handler as a property to our XHTTP request object, just like we did up here for our API return handler, this API error handler, because it is assigned to the onError property of the XHTTP object, this actually becomes a function or method of this object, which means we can access that object using this. So again, we can say console.log, and we can say this, and we can actually print out in our console the entire XML HTTP request object, which we have as XHTTP. So let's go ahead and jump back here and see this. Here we've got our custom XML HTTP request object, and we can see that we've got all the properties and information that came back with it. And we can explore all of that. We can see right here, we've got the onError function that we provided. That's the reference to it. We've got our onReadyStateChange, which is our API return handler. This is, of course, the code that we've written to handle that. And these are the event handler properties. And then we can look at other information that this object provides us. It's got an upload object, just all kinds of nifty stuff. And so here inside of our error handler right here, we can go ahead and provide our user some information that an error happened, and potentially, depending upon what library we are using for our asynchronous web requests, we may have more information inside of the error object or more information inside of the actual request object that we can use to build a very informative error message for our user. So this has been basic error handling inside of an asynchronous web request to an API. Make sure that as you are building any widgets, a weather widget or any other type of widget that uses an API or a web service call, please make sure that you are handling error messages, especially the most common ones that can happen, and that would be the 401 unauthorized or the 404 not found, as well as errors that might happen if for some reason this web server goes down and the XML HTTP request object can never reach it. You need to make sure you're handling those exceptional cases using error handling, and that you are informing your user, which means if we were building a real application right now, instead of just printing this stuff to the console, we would actually be putting error messages up here, informing the user of what happened and what they need to do to fix it, and then providing them a text box in order to provide a correct function on the API or to provide the correct API key. All of that would be happening here inside of the browser in the HTML as a result of what happens here in the background in the JavaScript. Hopefully this helps. Hopefully you'll be able to build more resilient and more gracefully degrading applications as errors happen. Instead of allowing your scripts to just simply blow up, you're actually capturing those errors and providing valuable feedback to your users so that they can then mitigate or correct what caused the errors in the first place and then retry. This is a much better way and provides a much better user experience for your users in your applications than simply having things blow up and fail.